Thank you very much, everyone. It is truly an honor to be here. Our company was founded because in 2012, I became literally obsessed with the lithium metal battery. As you likely know, it was invented in 1977 by Nobel laureate Professor M. Stanley Whittingham while he was working at ExxonMobil. And it was a beautifully elegant battery with lithium metal on the anode and a cathode. He started with titanium disulfide, which did not contain lithium. Fast forward to today, everyone is holding in their hands the compromise, which is lithium ion. And back in the day, this battery was invented to power a Sony Handycam, right? Very low power, and no one was thinking about things like supply chain. And we wound up with a very complicated, resource-intensive battery that we're now completely dependent upon as a society, and there's not much clean or green about it. Lithium metal was the much more elegant solution, but what I learned as I began to dive into it is that it's intrinsically cleaner to manufacture, which was a big surprise, that, whoa, there could be the dream of a better battery that actually is cleaner. If you look at the lithium ion supply chain, all of these materials are sourced globally, but 90% of them are refined in China. In fact, 99% of graphite is produced and made in China. That's 55,000 miles around the world. Forget geopolitics. The amount of travel that the lithium has to do to get from the ground inside your battery, in part due to the fact that it's intercalation chemistry and it goes from the cathode through all 3 weeks of intensive formation cycles into the graphite to form an anode. It's 55,000 miles around the globe in 587 days. And you have a clunky battery that relies in part on cobalt and nickel in a complex supply chain. Well, let's enter lithium metal. So what are some of the challenges with lithium metal? Well, only 7,500 tons of it were made last year, and it's a very energy-intensive process. It's molten salt electrolysis, high temperature, chlorine gas. It's generally made in China. It produces an ingot the way it's made, and there are two ways to get it into your battery, into an anode form. You can either vapor deposit it, right, which is a batch process and has all sorts of issues, or you can extrude it and try to, what I call the smush method, onto copper. Or enter electrodeposition, the most elegant form of chemistry there is. It's how a lot of copper is made. It's how a lot of nickel is made. It is not rocket science. It's simply applying this elegant technique and using aqueous chemistry. I started with this idea to dissolve lithium carbonate in some sulfuric acid and pass it through an ion-selective membrane. The membrane was completely unscalable. But what it did produce back in the day is this beautiful lithium metal deposit with a chemical bond to the copper. And if you look at a phase diagram, you will see that 13% of lithium will dissolve into copper. You form a very nice bond. Then you plate the lithium on top of it, and you can get a beautiful 20-micron electrode, which is what you need in the battery. We named the company Pure Lithium because you need pure lithium in your battery. I've done more studies on the existing supply of lithium and side reactions and impurities. We're on the ISO standards committee for purities in lithium. You can't have boron and sodium in a lithium metal battery. People want to know why dendrites form and the battery doesn't work. Go back and read Natasha Balsaler's paper in 2015 where he isolated the source of impurities at nitrogen in the commercial supply of lithium. We've achieved over 5,500 cycles in real, actual pouch cells, not coin cells. We pair our battery with a basically delithiated LFP cathode, which will be our first generation product, and the holy grail, going back to Stan's work, is a vanadium oxide cathode that we're working on, which can get you up to 400 watt-hours a kilogram. Vanadium is also sourced readily availably in the United States because it's a byproduct of oil production. You don't even need to mine vanadium. So we have invented a better way to make lithium, and guess what? It's actually affordable. Today's battery is around $100 a kilowatt hour. Even if the battery is 4 times as good, it can't cost $3,650 a kilowatt hour of just lithium metal. That doesn't work. So we take aqueous brine and we electrodeposit it through an intermediate electrode, which is basically LFP, and a membrane that we're scaling in partnership now with Saint-Gobain, the large French company. And it blocks water because lithium metal doesn't love water. It just turns into hydroxide. And it selectively pulls lithium out. It's a fast process. I can make a complete battery in a charged state in a day, not 587 days. And It's half of the weight of today's battery. We eliminate graphite. It's so much easier to recycle. If you make the battery in a charged state, you can just fully discharge it or charge it, pull all the lithium off to one side, and you can recover it. We have over 120 patents that my team developed in Boston. We're moving to Chicago because we're going to commercialize this technology to make our lithium metal battery, and we have abundant power, and there are a whole host of reasons I won't bore you with. But the dream today is that we're going to have a better battery, and the absolute amazing fact to me is that if you make this battery, you can actually make a battery that is cleaner and better. And I'm not going to stop until everyone in this room has a safe lithium metal battery that is economically viable and that cuts this complicated supply chain that relies on the processing of lithium carbonate and lithium hydroxide, which are complicated processes that include roasting and also use a tremendous amount of fresh water. We're literally ruining aquifers all over South America. You need between 1 and 2,000 cubic meters of water for 1 ton of a carbonate product, and we don't use any fresh water. So I want to thank my team, and I really want to thank the very inspiring talk of Paul and the American Chemical Society for making this happen and inspiring all of us to do better and start companies, because we know we can actually make a big difference. So thank you.